ተማሪዎች ባለፈው ሌሰናችን የመጀመሪያውን የዩኒት 3 አይተናል። ጥያቄዎችም ጠይቂያችሁ ነበር። ብዙ ተማሪዎች ሰርታችኋል፣ የሞከራችሁም ተማሪዎች አላችሁ። ስለዚህ የባለፈውን ሌሰን እንዲሁም ዛሬ ከምንቀጥለው ሌሰን ጋር አያይዘን መልሱን ደግሞ አብረን ለመስራት እንሞክራለን። ስለዚህ አንዳንድ የሞከራችሁ ልጆች ደግሞ አልፎ ትንሽ ክፍተት የተፈጠረበት ቦታ ስላየሁኝ እስኪ ድጋሚ የምታስተካክሉት ካለ እድል ሰጥቻችኋለሁ። ስለዚህ ሌሰን 2 ከጨረስን በኋላ በቀጣይ አንድ ላይ መልሶቹን እንሰራችኋለን ማለት ነው። ኦኬ in today's the second lesson is coordinate covalent bonding. Coordinate covalent bonding. In last class discuss about a chemical bonds. What mean by chemical bonds? Also discuss about ionic compounds. Ionic compounds are formed by transfer of electron metal to non-metal with different electronegative values. Also discuss about covalent compounds or covalent bonds. Covalent bonds are formed by sharing of electron between two atoms. In today's discuss about coordinate covalent bonding and resonance structure. Also exceptions of some covalent compounds. Okay, student, what is coordinate covalent bonding? Therefore, this coordinate covalent bonding is a bond. Both shared electrons are donated only by one atom. Examples of coordinate covalent compounds: NH4 plus ammonium ion, H3O plus. These types of species contains coordinate covalent bonds. CO. Another example, NH3 BF3. From these types of species contains coordinate covalent bonds. Please look some explanations. 1, NH3 BF3. NH3 is ammonia. Look, NHH. You know hydrogen is contains 1 valence electron, 1, 1, 1. Each hydrogen is contains 1 valence electron. You know nitrogen is group 5 element. Group 5 elements are how many valence electron? 5 valence electron. Therefore, 1, 2, 3, 4, 5. Between nitrogen and hydrogen, sharing of electrons takes place covalent bond. A student, how many covalent bond? Yes, 3 covalent bonds, because this bond and this bonds are formed by sharing of electron between nitrogen and hydrogen. This is lone pair. Therefore, nitrogen contains 1 lone pair, and nitrogen with hydrogen, 3 bonds are formed. These 3 bonds are known as bond pair. This bond is covalent bonds. BF3, look, BF. B is boron, F is fluorine. Boron is group 3 elements. Because of group 3 element, it contains 1, 2, 3 valence electron. Boron is group 3 element. Because boron atomic number is 5. 5 means 2, 3 valence electron. Therefore, 1, 2, 3. Fluorine is group 7 element. Halogen, group 7 elements are how many valence electron? 7 valence electron. Therefore, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Each fluorine contains 7 valence electrons. One of the electrons of fluorine with boron forms a covalent bond. Forms a covalent bond. Forms a covalent bond. How many covalent bonds in BF3? 1, 2, 3. How many covalent bonds in ammonia? 1, 2, 3. But these two are separate. Between the central atom ammonia nitrogen and the central atom boron, the bond must be formed. But covalent bonds are not formed. Why? Because there is no electron in boron. There is no share of electrons that takes place between nitrogen and boron. But by contribution of nitrogen, any bond can be formed. Look, these two electrons are, a bond is formed between nitrogen and boron. Please, student, this bond is not covalent bond. This bond is not covalent bond, but covalent, covalent, covalent. Why covalent? Because of sharing of electron. Covalent, covalent, covalent. Why? Because of sharing of electron. But this is not covalent bond. Why? Because these bonds are formed by only the contributions of nitrogen. Nitrogen contributes to electron, boron, there is no any contribution. Therefore, this is a new bond can be formed. This new bond is known as coordinate covalent bonding. Coordinate covalent bonding. Is there any covalent bond? Yes. How much? By the way, NH3, BF3s, this is one compound. How many covalent bonds? Excellent. 6. 1, 2, 3, 4, 5, 6. 6 covalent. How many coordinate? 1. Between nitrogen and boron. Which one is donor? Nitrogen. Which one is acceptor? Boron. This types of bond is donor-acceptor bond is known as coordinate covalent bond. Sometimes in grade 9 discuss about dative bonds. Dative bond, nitrogen is donor, boron is acceptor. This bond is coordinate covalent bonding. Okay, another representations for coordinate covalent bonding is indicated by CO. CO. Carbon monoxide, carbon with oxygen. Carbon is 4 valence electron because carbon is group 4 element. Oxygen is group 6 element. Therefore, this bond can be formed. A student, this is known as what? Lone pair. This is lone pair. The correct Lewis structure of CO is this one. This one. This bond is triple bond. Look, carbon is 4 valence electron, but 1, 2 here. But 1, 2, 3 plus 2 is 5. Therefore, one bond is from the 3 bond. One of the bond is contributed by only oxygen. One of the 3 bonds. For example, if this one is covalent, this one is covalent, this one is must be coordinate covalent bond. Or this one is covalent, this one is covalent, this one is coordinate covalent bond. Because 3 bond plus 2 is 5. One of the electrons are contributed by only oxygen atom. For example, if this one is coordinate covalent bonding, these two are covalent bonds. Because carbon contributes maximum how many electron? 4 electron. 1, 2, 3, 4. One of the bond is coordinate covalent bond. But this one of the bond is not only for this one. Therefore, triple bond, but one of the bond is coordinate covalent bond. The other 2 bond is covalent bond. Therefore, in CO, one is coordinate covalent bond, 2 is covalent bonds. This is for coordinate covalent. Therefore, CO contains coordinate covalent bonds. The other point is resonance structures. resonance structures. Students, what is resonance structures? What is resonance structures? Resonance structures are a molecule or ion that can be represented by two or more Lewis structure. One molecule, two or more Lewis structure. These types of molecules or these types of structure is resonance structure. The resonance structure differ only the distributions of electrons. Resonance structures differs only the distributions of electrons. Examples of resonance structures. Example, O3, N2O4, CO3 2 minus, NO3 minus, HNO3, NO2F, and so on. All these species contains resonance structure. Resonance structure, a substance or a species, it contains more than one Lewis structure. For example, look, O3, ozone, O3. In O3, the structure is look like this: oxygen, this is the Lewis structures of O3 or ozone. The double bonds are not only for this position. The other alternative, oxygen, single bond, double bond. Double bond is rotated. Oxygen 1 2 1 2 1 2 1 2 1 2 1 2. This is the Lewis structures of O3. Both structures are satisfied. This is resonance structure 1 and 2 is resonance structures. Resonance structure. This is again resonance structure. These double bonds are rotated. Therefore, O3 two possibility. A species or a substance more than one Lewis structure is known as resonance structure because of double bond rotating the position, because the same position, oxygen, 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 oxygen. The only difference is what? The distributions of electrons. This is the resonance structure. Collectively, this one is formed again possible. Oxygen, oxygen, 1 2 3 4 1 2 3 4 2 dot by using of dot dots. A student, a structure one is a resonance structure. The second one also resonance structure. What about this one? This is a resonance. Yes, yes, a resonance hybrid. A resonance hybrid. Resonance hybrid. In resonance structure, oxygen with oxygen, or this oxygen with this oxygen means the central oxygen and the surrounding oxygen, the same bond lengths, the same bond strengths. Therefore, this is single bond, this one is double bond, but double bonds are rotated. The lengths of oxygen with oxygen, this one, oxygen with oxygen, the same bond lengths, the same bond strengths. The amount of energy required to break this bond and this bond is the same because of resonance structure. Therefore, O3, how many possibility? Two possibility. One is this one, the other one is this one. Draw the Lewis structures of NO3 minus. Okay. First, nitrogen. 1 times 5, 5. Why 1? Because 1 nitrogen. Why 5? Because nitrogen is group 5 element. 1 times 5 is 5. Next is oxygen. How many oxygen? 3 oxygen. 3 multiplied by 6. Why 3? Because 3 oxygen. Why 6? Because oxygen is group 6 element. Group 6 elements are 6 valence electron. Next, 3 times 6. How much? 18. Look, the charge is minus. Minus. Minus means gain. Plus, lose. Minus is gain. How many electrons are gained? 1. Therefore, plus 1. 5 plus 18, 23, plus 1, 24. This 24 is what? This 24 is what? Total valence electrons. Total valence shell electrons. Total valence shell electron is 24. What is the central atom? What is the central atom? Nitrogen. Look, nitrogen, how many oxygen? 3. Oxygen, oxygen, oxygen. First use a single bond. 1, 2, 3. 3 single bond, how many electron? 6. But total number of electron is how much? 24. 24 minus 6, how much? 18. First, always electrons are gives for the surrounding atom. How many electrons are requires or needs oxygen? 6. Why? 2 plus 6, 8 to satisfy the octet rule. Therefore, 6, 6, 6, 6, 6, 6. 6 times 3, 18. 18. 0. The remaining electron is 0. There is no any remaining electron. There is no any remaining electron for nitrogen. In this case, nitrogen satisfies the octet rule? No. Oxygen satisfies the octet rule? Yes, but this oxygen, the formal charge is not 0. This is not the plausible Lewis structure. This is not the acceptable Lewis structure. A species not only for satisfies the octet rule, also satisfies the formal charge. Therefore, by the way, student, you know formal charge? Formal charge can be calculated by formal charge. Look. Formal charge can be calculated by, for example, look, O6 for this oxygen. Formal charge means valence electron for oxygen. How many valence electrons for oxygen? 6, 6, minus. This oxygen forms how many bonds? 1, 1, minus. This oxygen, the remaining electron is how much? 6, 6. What is the result? Minus 1. By the way, the best or the acceptable formal charge is 0. 0 is the best. Therefore, formal charge of oxygen, in this case, 0. No, how much? Minus 1. Therefore, minus 1 is not satisfied for this oxygen. This oxygen also formal charge, not 0. Therefore, this structure, less for by using of a double bond here. A double bond here. For example, always for a species, a negative charge uses like this square bracket and finally minus. Therefore, what is the possible Lewis structures of NO3? Uses a double bond. In this case, uses a double bond. This 6 is converted into 4. The structure is look like this. The structure is nitrogen at the center, oxygen here, another oxygen here, another oxygen here. Uses, don't forget, square bracket, minus. If plus is plus, minus is minus, minus 2 is minus 2, and so on. Any species uses a charge, uses square bracket, 1, 2, 3, single bond. Double bond can be formed, 6 converted into 4. Because of single bond, how many electrons are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Single bond 6, double bond is 4. This is one of the resonance structures of NO3 minus. What is the other possibility? The other possibility is rotating the double bond in another position. Therefore, the other alternative for this one is, nitrogen, oxygen, oxygen, oxygen. Look, the double bond rotate from this position. This is possible. Double bond, single bond, oxygen. 1, 2, 1, 2, 1, 2. 1, 2, 3, 4. 1, 2, 1, 2, 1, 2. This is the other possibility. The other possibility also rotating the double bond from this position. Therefore, nitrogen, double bond, single bond, oxygen. Uses minus charge. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Therefore, NO3 minus, how many resonance structures? NO3 minus 3 resonance structures. Structure 1, structure 2, structure 3. Exceptions to the octet rule. Exceptions to the octet rule in covalent bonding. Exceptions to the octet rule in covalent bonding or in covalent compounds. Exceptions to octet rule in covalent bonding. 3 groups are existed. One is less than octet. Less than octet. 2 above octet. Above octet. 3 odd number of what? Odd number of what? Excellent. Odd number of total valence electrons. The first one, less than octets. The name indicates less than octet. Octet means 8. Less than means less than 8. Some covalent compounds do not obey the octet rule. Total number of valence electron on the central atom is less than 8. Example. Sometimes, by the way, less than octet or incomplete. Incomplete octets. For example, BeF2, beryllium fluoride. BF3, BCl3, and so on. These types of compounds are covalent compounds, but do not satisfy the octet rule. What is the central atom here? Beryllium. Beryllium is contains 2 electrons, 1, 2. The surrounding atom is 2 fluorine. This is the structure for BF2. Therefore, fluorine is group 7, 1, 2, 1, 2, 1, 2. Finally 7. Therefore, 1, 2, 3, 4, 5, 6, 7. Because fluorine is 7 valence electron. 1, 2, 3, 4, 5, 6, 7. Each fluorine 7 valence electron. Between beryllium and fluorine, a bond is formed. This bond, covalent or coordinate? Covalent. Why? Because these bonds are formed by sharing of electron. Another sharing of electron is covalent bond. Covalent bond. But the central atom, beryllium, it satisfies octet rule? No. Why? Because around beryllium, total number of electrons is less than 8. Look, 1 bond, 2 electron, 1 bond, 2 electron, 2 plus 2, 4. 4 electrons. 4 electrons around beryllium. 4 electrons around beryllium. Therefore, 4 is less than 8. 4 is less than 8, less than octets. Therefore, beryllium fluoride do not obey the octet rule. Another example, BF3. What is the central atom? Boron is 3 valence electron. Therefore, 1, 2, 3. How many fluorine? 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. A covalent bond is formed by sharing of electron. By sharing of electron, covalent bonds can be formed. How many electrons are around boron? How many bonds can be formed? How many bonds are formed? Or how many sharing of electron? 1, 2, 3. 3 means 6. Therefore, 6 electrons are around boron. Therefore, 6 is less than 8. Therefore, boron trifluoride or boron trichloride. By the way, BF3 and BCl3, fluorine and chlorine, both are group 7 elements. There is no difference in Lewis structure. The only difference is fluorine and chlorine. Therefore, both these types of structure do not obey the octet rule. The second one is above octets. Above octets. 2 is above octets. Above octet means more than octet. It is more than octet, which means total valence electron or total electron around the central atom is greater than 8. Example of molecules under above octet, because some covalent compounds are more than octet. What types of compounds are more than octet? For example, SF4, SF6, PCl5, XeF2, XeF4, and so on. This is different types of covalent compounds, but do not obey the octet rule by more than octets. For example, SF6, sulfur. How many surrounding atom around sulfur? 6. 1, 2, 3, 4, 5, 6. Each fluorine contains how many electrons? 7. 6 plus 1, 7. The student, please assume 6 means 6 dots. Therefore, sulfur is group 6 element. 1, 2, 3, 4, 5, 6. Each fluorine atom contributes only 1 electron. But 7 valence electron, its contribute for covalent bonding is 1. Look, covalent bonding, covalent bonding, covalent bonding, covalent bonding, covalent bonding, covalent bonding. A student, how many covalent bonding? 1, 2, 3, 4, 5, 6. 6 bond means how many electron? 12 electron. Therefore, 12 electron around what? Around sulfur. Therefore, 12 is greater than 8. Therefore, again, this is more than octet. Therefore, SF6 do not obey the octet rule. Please, student, at home, try the Lewis structures of SF4, PCl5, XeF2, XeF. By the way, Xe, group 8 elements. At higher temperature, group 8 element xenon forms a bond. Therefore, xenon 8 electron at the central atom, xenon F4, this one is xenon F2. Please show the Lewis structures of the other molecule. The third one is odd number of total valence electrons. By the way, a compound, a covalent compound, total valence electron is odd, always do not obey the octet rule. Under odd number of total valence electron, example, NO, NO2, ClO2, and so on. Look at the structure of NO, NO. Nitrogen. How many valence electron? 1. 1 times 5, 5. Oxygen, 1 times 6, 6. Total number of electrons is how much? 11. 11 is what type of number? Odd or even? Odd. Odd. Therefore, total number of electron always odd, do not obey the octet rule. But the Lewis structure of NO is this one. This is the Lewis structure of NO. Look, 1, 2, 3, 4, 5, 6, 7, 8. Oxygen satisfy. But nitrogen, 1, 2, 3, 4, 5, 6, 7. Total number of electron in nitrogen is 5. 1, 2, 3, 4, 5. Oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Please, students, try the structure of NO2 and ClO2. The Lewis structure of NO2 and ClO2. Until next time, goodbye, student.